Assalamu alaikum students. Article for today is dimensions. Now what dimensions are? Dimension basically describes the nature of the physical quantity. Like for example, there is a quantity called radius, there's a quantity called distance, there's a quantity called length, there is a quantity that is known as the displacement. So what are these? These are basically belonging from the same, they are having the same root, but these are the different names of basically distance. So this these dimensions basically describes the basic nature of the physical quantity, that basically this quantity is what it is: a length, it is a mass, or like as you see that you are having an example of having time and time period. Now what is the difference between both of them? Basically both are time, but this is known by the fact of the dimensions. Dimension basically tells us that what is the basis of that physical quantity, right, what is the nature of that. So every basic physical quantity, it is represented by a specific symbol written within square brackets, and these are definitely written in the capital letters, and these show that how this quantity is going to be exhibited. Like for example, we have some basic dimensions which are length. For length we are having L, that is L, capital L, and written in the square brackets, right? So this would be the dimension of length. And then comes mass. For mass we are having M. Then time and duration, we are having T for that. Then comes the electric current, we are having I for that. Thermodynamic temperature, we are having you can say this is a specific symbol known as theta. And then comes the amount of substance, that is N. And then the luminous intensity, that is J. So these are the seven physical quantities and their dimensions as well, right? So next, if there are any further dimensions have to be derived, like for example for force, for the other derived quantities, then we will derive all those dimensions from these basic dimensions, right? For example, we are having these examples, like for we are having velocity. For velocity, the formula is basically d by t, right? So for d we are having the displacement, that is L. For the dimension of t is t. So when t will move to the upside, we will get t minus. So this is what I was talking about, that we are having v and then L and t, then LT minus 1, right? For this kind of thing we are having for acceleration. Then for acceleration, what we are going to have, we are having acceleration dimension, and then this would be equal to v by t, right? The formula is v by t, and the dimension of v is LT minus 1, which we already have derived just a little few moments later, and t again. So this is the formula, that is v by t. So this will become LT minus 2. So that's how we are gonna derive, or you can say find out the dimensions of the different physical quantities. Then comes the force. Then again, force, the formula would be definitely like for the formula for the force is F equals to, so I can write F equals to MA. For M we are having the dimension, that is M for mass, and for A we have already derived it, this is basically LT minus 2. So on combining both of these two, I get MLT minus 2, right? So this is basically the dimension of force. And similarly work and so on for the power, and for any other derived quantities using the same strategy, you can find out easily the dimensions, right? Okay girls, now there are some terms which are associated with the dimensions, like for example dimensional variable, right? So what is meant by dimensional variable? Dimensional variable is such a quantity which is having dimension and its magnitude is variable as well, right? Having a dimension and a variable magnitude, right? So in this case, coming towards the examples, we have, for example, example of force, example of acceleration, or you can say power, or anything like that. We can put it in the examples of the dimensional variables, right? Now coming towards the dimensionless variables, that means that magnitude of that quantity is variable, right? But it is not having any kind of dimension, right? For example, there is a constant that is a quantity that is known as plane angle, which you have already studied, plane angle or the solid angle, right? So both of these come under this branch, for under this term. And there's another example known as strain, right? So you must be witness that what about strain. So strain is basically something that is L divided by L, right? So it is not having any unit, that means it is not having any dimension, but strain is having some kind of value, right? Like 24 or 43 or so on, right? So that's how it is dimensionless, but it is variable. Do remember, all the quantities which are not having any unit, they come under dimensionless, right? Next is dimensional constant. Dimensional constant, what is meant by dimensional constant? Dimensional constant is such a quantity which is having dimension but its magnitude is constant, right? For example, we are having Planck's constant, we are having gravitational constant, right? These are the kind of physical quantities that their magnitude is constant, but definitely they are having some unit, so definitely they are going to have some dimension as well, right? And now the last but not the least, that is dimensionless constant. And dimensionless constant are those constants or those quantities whose magnitude is constant, right? And they are also dimensionless, right? So for example, what we are having a number that is pi. Its value is constant and it is not having any unit or any dimension. There is a number called 1, 2, 3, any number, up to so on, any whole number, or any integer or anything like that. It is not having any kind of dimension and it is a constant as well, right? So that's how these are four terms are associated with dimensions, and I think you have understood all of these. Okay, moving towards the advantages of dimensions. Basically, there are three advantages which we are going to study. The first one is checking the correctness of the physical equation, right? Like, how can we check that this particular physical equation is correct? How we will check it? Basically, we are going to derive the dimensions on both sides, right? And at the end, we will see that the dimensions on the left hand side is equal to the dimension of right hand side or not. If it is equal, then the equation is physically correct, right? Dimensionally correct. And if it is not, then that equation is not going to be considered as dimensionally correct, right? So in this example, you can see that we are having example 1.6, and in this example you can see we are having the drag force. And they are asking that which formula would be correct for the drag force, right? And okay, sorry, it's not basically the drag force. They are basically asking that which of these formula is correct, right? If it is F equals to mv square over r square, is this formula correct? Or F equals to mv square over r, this formula is going to be correct. So I think this is the formula for we already know that this is the formula for centripetal force. So now we are gonna check the homogeneity of the equation. What is meant by the homogeneity? Homogeneity means that this equation is going to be correct on both sides, like left hand side should be equal to the right hand side, right? So coming towards the right hand side, we see that we are having F equals to mv, right? Okay, we are having only F. If I talk about the left hand side or the right hand side, we will separately derive the dimensions on both sides and then we will equate them. Okay, so you can see here that now we are going to have that left hand side and the right hand side as well. So what I'm gonna do, I'm going to solve it like this, if, which is a more convenient method, f equals to mv square over r, right? Now in this condition you can see that we are going to have the formula for f, a dimension for f, and then for v square over r as well, right? So I'm gonna shift this mv square over r on the other side. It would be like, so as you can see here, we are having mv square over r, and dimension of m is m. For v square, we are having lt minus 1 square of that, and for r, we are having again l. So we are going to take square of this dimension. It will become m l square t minus 2 square. Do keep this thing in your mind that the dimension is not going to be positive if you take square of that, right? So in this circumstance, so as you can see here, we are having ml, we have after taking the square, it will become ml square t minus 2l. So there is l in the denominator and there is l square in the numerator, so I think we can cancel it out. And when will cancel it out, what is going to be left over here, it will be like ml ml t minus 2, right? So mlt minus 2, which is the same answer we got over here. So that's how we are gonna solve it, that we get the answer mlt minus 2, and this mlt minus 2, this side of the equation is equal to this side. So I can write left hand side is equal to right hand side, so this is going to be correct, right? I don't need to solve the other formula, that is mv square over r square. And if you want to calculate it, you can do it by this method. There is method given. Our right hand side, that is again mlt minus 2, then left hand side, so we'll calculate it for that. And that's how we are going to calculate, that is ml square t minus 2, that is divided by l square. And as a result, what we are getting, we are basically getting ml t minus 2, right? So we can do this method, and we can prove that the second formula, that is mv square over r square, is not correct, right? So that's how you can prove that this equation is dimensionally correct or not. Moving towards the next advantage, we are having that can we derive a possible formula, right? So for that we are going to understand that, like, if I don't know the formula for any physical quantity, how can I derive it? So I would definitely see that on which basic quantities on which it is depending. Like for example, here there is a solid sphere which is moving through a liquid, and the liquid opposes the motion with the force F, and the magnitude of force is depending upon the coefficient of viscosity, that is eta. And the dimensions of eta are given, ml minus 1 t minus 1, and the radius r of the sphere, and this b to v, right? So assuming the force to be proportional to the all of these, directly proportional to all of these quantities, we are going to find out the formula, possible formula for drag force, right? So what we are going to do, that firstly we are going to say that all of these quantities are directly proportional to the drag force, right? And the very important thing is that we don't know that these physical quantities are with some power or not, right? So what we are going to do, we say that this drag force is directly proportional to the first thing, that is eta. I don't know the dimension formula for eta, so I'm gonna write a constant, or you can say an exponential, that is a. Or the next one is for drag force is also directly proportional to the next thing they have given, that is the radius. I don't know that there is going to be a square or not, so I'm gonna put a constant, that is exponent, that is b, right? And then the last thing, that is the velocity, simply that it is. So I'm gonna write it with c. So all of the three drag force dependence, the quantities that are depending upon, directly depending upon the drag force. So now, combining together and clearing this sign of proportionality, what we get a constant, and along with that an equal sign, right? Now, as dimensions don't provide any information regarding these constants, so leaving that behind, putting the dimensions on both sides, what we are getting for the force, that is ml t minus 2, and putting the value of the dimensions on other side, eta's dimensions are given, that is ml minus 1 t minus 1 raised to power a, right? This is the power. And coming towards radius, it is having dimension l, having a power b. Then comes v, it is having dimension l t minus 1, having a power c, right? So now in the next step, what we are going to do, that we are going to combine all the like powers, right? All the bases which are same, we are going to add all those powers. So for that, what we have done, there is mass singly, so we are going to write m raised to power a. L, we are having minus 1 is multiplied with the power, right? So this l minus 1, this l minus 1 is multiplied with the a power. So power is multiplied, and what we get, minus a. So that's why they are mentioning minus a over here, right? And then comes to b, there is positive 1, so I'm going to write plus b. And the c as well, c is going to be also positive, right? As this one is going to be multiplied with this c, right? So that's how we are getting minus a plus b plus c for l. Then coming towards t, we are having two t's over here. So first would be minus 1 into a, it would be minus a, and for the other one it would be minus c, right? So that's how all of these physical quantities are made separated on the basis of their um, um, exponents, right? Now comparing on both sides, what we are going to do, that we are going to compare the bases on both sides, right? Like m on the left side and m on the right side, and we are going to compare their exponents, we are going to compare their powers, right? So for that, for m we are having plus 1 on this side and a on this side. So what we are getting, that is a equals to 1, right? Next for the t, we are having t minus 2 on this side, and t raised to power minus a minus c on this side. So putting these values, what we are getting, that is minus a minus c equals to minus 2, and we are having a equals to 1, as we have already derived. So now putting the value of a, what we get, the value of c to be 1, right? Now the last thing for L, we are having L raised to power 1 on this side, on the left hand side, and on the right hand side we are having minus a plus b plus c. So equating all of these, we are having a and c, and we can compute easily the value of b, which is going to be b equals to 1. Okay, now putting all the values over the exponents, right? The exponents were a, b, c. Now going to, if I put the value of a, b, c in the final formula, it would become k eta raised to power 1, r raised to power 1, v raised to power 1. So all of these quantities are directly proportional, as you can see. If there is any quantity which is indirectly proportional, we get minus 1 for its power. So that's how we can derive the formulas, right? And since dimensions don't provide any information about the constants, this constant is going to be find out later on, and it comes out to be 6 pi, right? So that's how we can derive a possible formula for any physical quantity. Okay, the last one is, how can we find out the unit of any physical quantity? Like for example, we are having f equals to, we know the dimension of f, it was mlt minus 2, right? This was the dimension of force, right? I know that. How can I derive the unit from this? Simple, very simple. M, the unit would be kg. L, the unit would be meter. And for t, it would become per second square, right? So that's how we can easily determine the unit. If I remember the dimension, I can easily find out the unit of that physical quantity. Okay, moving towards the limitations of of dimensions. Dimensions basically do not provide any information about the constants, as we have seen earlier in the in the example of drag force. We see that there is no information about the k, right? So it does not provide any information about the constants, right? Like 1, 2, 3, 4, pi, or things like any numbers if associated, 1 by 2 and so on. Now it also don't provide any information about the trigonometric ratios like sine theta, cos theta and so on. And it does not provide any information. It also don't provide any information about the logarithmic functions, like for log of this and log of that. No dimensions for that. Exponential functions, no dimensions for that, right? And the last limitation is that dimensionally correct equation needs not necessarily to be physically correct. As you have seen, that we have derived the formula for the drag force. Dimensionally, it was F equals to eta r v. But this is not a correct physical equation. The correct physical equation is 6 pi eta rv, like, right? Giving you another example, we are having the formula for time period. It is t equals to 2 pi l over g, under root l over g. When we derive the formula, this comes out to be t in terms of dimensions, t under root l by g. We don't get any information about 2 pi. This is dimensionally correct. T equals to under root L by G. This is dimensionally correct. But it is not physically correct. For that to be physically correct, we have to put the value of the constant. So if I put the value of constant, it is 2 pi, then this equation is going to be physically correct as well. So this is the limitation of dimensions, and hope you are clear now and the whole of the article is understood. Thank you so much. Allah Hafiz.